So what we see in this graph is the number of people that's having food due to artificial fertilizers. So what you can see here is that from up to around 1940, there were about 2.5 billion people on this globe, and most of the people were actually consuming foods without the influence of synthetic fertilizers. And up to now, it's nearly half of the population that has food thanks to this fertilizer. So it's causing, nitrogen is causing a lot of environmental problems, but on the other hand, it's rather essential for feeding global populations. And the same can be told about the forests that are not used, because if you don't apply this synthetic fertilizer, the yields are much lower than presently, and that means that you need extra land. So this is an example where they calculated the land that's spared because of we increased the production of our agriculture system. So there's a heavy trade-off between using fertilizers and deforestation. But on the other hand, the fertilizers and the pesticides are not naughty stuff. So this is also from our World in Data, and it shows the pesticide use and the fertilizer consumption on a global scale. And what I mentioned earlier, you can also create this graph yourself for your own country. And you see that from the fertilizer consumption increased from 1960 onwards, and pesticide use from 1990 onwards. So these two, the pesticides and the fertilizers, were needed to increase the yields, and as a consequence, we were able to use less forests. So it's an extremely complicated system. And so the fertilizers and pesticides are harming ecosystems, and on the other hand, we are needed them to have a high agriculture production, and the high agriculture production makes it possible to use less forests. So it's not an easy puzzle to solve. So this is a picture on the huge the nitrogen surpluses in some countries of the world, and even in some countries there's still a shortage. So in Africa there's still too less nitrogen available for proper agriculture. So this is the present knowledge. So this is what we came up in the last 25 years. And this is the link I mentioned to our World in Data. Please go there, and they have very nice material on it. You can make graphs, but there's also very nice text on discussions going on. So the discussion on whether we should use less fertilizer and do something, start deforestation, of that, all these academic discussions on what's the best way to provide food for the global population, but also reduce the environmental impacts of this food system. So the most dominant environmental problems are on a global scale are caused by the food production, but the best way to reduce this is to stop eating, but that's not a social solution for this issue. So we are in an extreme complicated situation. So we need healthy food for a global population, and on the same way we need to avoid destroying the global environment. So what are the options to solve this? So there's in principle two ways that really have a good look on the agriculture systems. Can we go for a biological system? Can we reduce fertilizers? Can we reduce pesticides, etc.? But there is also another way, and that's looking at what we are eating. Because we know that we need a certain amount of protein, fat, etc. to stay alive and to stay healthy, but it can be provided by different things we are eating. So if you want to know what the environmental impact of the consumption is, you have to know what the impact of individual food items is. And what we do in this case is that we use the chain analysis, and what we start to do is calculate footprints. So, and a footprint means that you calculate, so if it's a water footprint, then you calculate the amount of water needed to produce bread or whatever. Excuse me. And that's the same for the carbon footprint, land footprint, and the nitrogen footprint. So it calculates how much of a resource is needed to make a certain food item. And what you do in this chain analysis is that you think on how it's produced. So if you do, for instance, an energy footprint of bread, then you first need to know what the farmer is doing to make the wheat. So we need to plow the land, and he needs so the grain harvested, etc. So in that case, you need to know how much diesel this farmer is using for doing this plot. And if you know this, then you have to know, if you want to eat meat, how much of the wheat you need for feeding, in this case, pigs or chicken or cows or whatever. So you need to know the feed conversion factor. If you get something from the food industry, you need to know how much energy is used for making sugar in a factory or to make pasta or whatever. You also need to know what energy is needed in supermarkets, because there's awful lot of cooling going around. And finally, you need to know the energy needed in transporting. And you have to do this for all individual food items. So you can imagine that it's a huge amount of work, because it takes you half a year to figure out the energy requirements for making pasta or whatever. So we started to do this long ago. So for instance, this is one of our first calculations, and it's around already in 1999. And this was the first time that we calculated the greenhouse gas emissions related to the total food consumption. We started with greenhouse gas emissions, and our institute is also having a master program. So we used our master students actually to calculate all these emissions, because we don't have time to do it. We wanted to do it for 120 food items, so for bread and for pasta, and our students actually did part of the job. But it's already 25 years ago, and at that time there were only 20 people on this globe interested in this subject. So we had very small meetings, workshops every 2 years where we met each other. But in the rest of the world, the idea existed that everything coming from agriculture was good and green. So in this time also biofuels were suggested, and bioplastic. It was all based on the fact that agriculture is not harming the environment. And presently we know that's not the case, but 25 years ago there was only a very small group of scientists interest of looking at this environmental impact. And when we were meeting every 2 years, everybody was so happy that we didn't have to explain that food production had an environmental impact, because we were all in the situation that we were the only one in the institute that are actually worried about environment and food. So we did the first analysis in 1999, and it was on greenhouse gas emissions. And a couple of years later, we did the same for land required for food. So we started to do all and then we got, and we also did water. And then we got the first results, and you have to imagine that nobody knew at that time. So we were having the results. So this is the type of results we had 25 years ago. And we are quite surprised. So this is showing on the front, it's the energy, land, and the water required for making a kilo of vegetables or a kilo of cheese. And what you can see, so at that time, there were vegetarians among us, but if we were replacing the meat, we changed to cheese. And what we saw in our calculations, that the environmental impact of cheese is actually as large as the environmental impact of meat. So at that time, this was a very new insight. And we also came across, but I'm a bit worried, can I point? But Joel, can you see? Oh, I don't think I can. Oh, maybe I can point.
You can also move your cursor. Maybe we can, yeah, you can point it. We can see. Yeah.
You can see this, yeah. So this
Yes,
is
we
the
can see it.
cheese. Yeah, thanks. So the cheese turned, to our surprise, having larger or the same order of magnitude environmental impact as meat. And we also find this rather funny. Here's the potatoes, that's very low. And the rice is, that's the next one, is far higher than the potatoes. And we were also a bit surprised here, but what you should realize is that what we are doing here is we calculate the resource per kilo. And a kilo of rice can feed more people than a kilo of potatoes. So what you can see here is that already calculating something in a per kilos unit turns out not to be the proper way, because a kilo of vegetable has a different function in a menu than a kilo of meat. So we already recognize that we should go to real total consumption patterns at that time. So this is the general view. So in principle, there's the bread and vegetables, potatoes have low impacts and the animal products have high. And presently, that's not real new knowledge, but at that time we were kind of surprised. We also did some comparison between different meat things, and then you can see that the beef is much higher than the pork and the chicken. And we also compared different types of vegetables. And what's interesting is how we made difference between open air vegetables, and that's vegetables grown just outside. But in the Netherlands, we have a large horticultural sector that's actually using fossil fuels to heat glass houses. And if you produce your tomatoes in a heated glass house, then the environmental impact is huge. Then we also had to look at drinks. So here in the front is the tea and the coffee and the beer, and later on you get the gin and the wine and the juices in. And again, here you see that per liter is probably not the proper way to express it, because I expected all of you are able to consume a liter of tea in a day, but you don't manage a liter of gin. So you should have a look on this. You really should understand the position of food item in your menu, because you can look for the product with the largest impact and try to kick it out of your menu. But if you only use it once a year, for instance, for a shrimp cocktail is rather polluting, but you only do it at Christmas, then you can kick it out of your menu, but it's not really having an effect. While if you are able to reduce emissions from milk, and where you use an awful lot of, then it has a far larger impact on the environment if you change your diet in that way. So this is data from 25 years ago. And in the meantime, academic world changed a lot. And here is an example of the present knowledge. And what you can see here on the bottom, it's based on a publication, Poor and Nemetschek, who collected all the data available. So presently there's awful lot of people doing footprints of whatever, of food in the world. And Poor and Nemacek collected all these data and made a publication of it. And Our World in Data makes a nice graphical story on this. But what you can see is that it's data based on 40,000, nearly 40,000 commercial farms. So it's really in 120 countries. So this is a real nice average. So what we did 25 years ago was just giving it a try. And what you can see that in 25 years, the amount of people involved in this part of science is huge. And it's now people know. And that for me, it's very interesting thing that in the 25 years that I was working on this subject, the knowledge really came to the people. So if we in the Netherlands, we ask a person on water footprints or the environmental impact of meat, people in the street know. And if I had been in another discipline like nanoscience or whatever, nobody in the street would have ever recognized the knowledge that we gained in 25 years. So, and the other interesting thing in this, that this Nemacek, he was one of the 20 people from 25 years ago that were in these small meetings. So he stayed in this subject very much in calculating and collecting. But what you can see here is actually the same picture as what we seen in the blue graphs earlier on. It's that the staple food, so the vegetable origin products have a low impact, and the beef and the animal products have far larger requirements. And they show the far more, so this is land use. It looks very much the same as what we showed. This is water use. This is eutrophication. So you can all get it from this website. And there's strong texts if you are interested in it on this issue. So what we can see if we merge them, that in general, the general conclusion is that, well, the staple foods, so the wheats and the grains and the beans, etc., have a low impact, and the impacts of especially the beef and the lamb are huge. And then you can look at what's happening in the total consumption pattern. So what we can see, if we just have vegetable, very staple food-based diets, we have a certain amount of environmental impact, and that's the lowest. So, and as soon as you start to increase, make it more rich, then so when you start eating meat, you easily double, and in some cases even more. If you use vegetable oil, it's adding up. Coffee and tea are adding. Beer and wine is adding. And then finally, we also throw away a lot. So this is a bit how it looks like. And lately, there's this making the whole picture for the whole food consumption pattern is also done. And this is the example for the EU. And it also shows it's the carbon footprint, so the greenhouse gas emissions related to food. And here is by food type. And what you can see is that it's over 80% of the emissions related, of the carbon emissions are 80% are related to meat and dairy. And there's a very small share here on the other stuff we are eating. We also did this for land use. And then you get this picture, that's our own publications. So this is the consumption. On the left hand, it's the food consumption in the globe per person. Over here, it's the calories. So what you can see is in that 1960, the average amount of calories available for a person on on this globe was about 2000, and it increased. So up to in 2000, there were 25,000 calories, 2,500 calories available per person per day. So the food situation increased a lot over 40 years. And you can, if you connect this consumption to land use, that's if you know the yields, you can do this. Then you can also calculate the amount of land needed for this production. And you see a heavy decline, and this heavy decline is caused by the increased yields in the 40 years we are studying now. But what you can, it's also divided in different things we are eating. And the brown at the bottom, it's the animal products. And then all the other things are the potatoes and the grains, etc. So in this area, you can see that now about 10%, and 10% of the calories are coming from animal origin, but it's already using a lot of the land. But the largest share actually is still in just the crops, so the vegetable products. So this is 40 years of global consumption, and you can also have a look for calculate doing the same for Western Europe, and then you see something else. In 1960, the consumption in Western Europe was already at 3,000, and it increased. And there's a huge amount, so there's already 30% of the calories are from animal origin. And this is the land use related to this consumption pattern. And you can see, so 30% of the calories are from animals or animal products, and more than half of the land is needed to produce this. So again, you can see that the animal products in our consumption pattern putting a huge impact on the total requirements of our consumption. So what we can conclude is that if there's a staple crop diet, that's far lower environmental impacts than the luxurious diets with meat and beverages, etc. So it really matters what you are eating for the environmental impact of your consumption pattern. And then it's nice to have a look on what's happening on a global scale to these consumption patterns. And what's a nice book is this one. It shows pictures from families all over the world on what they are eating in a week. At least that's what the book says, but I'm not so sure on this. So this is what we consider a luxurious diet. And this is a family in Germany. And yeah, according to the book, they are consuming this in a week, but I'm not sure that that's really the case, because I don't think that this huge amount of beer and wine here you consume is consumed by the two persons, grown-ups there. But in Western Europe, this is considered as, now at least people understand what to do with this. So there's the frozen pizza, there's juices, there's vegetables, etc. But the book shows far more families, but it gives, it visualizes what we consider as a luxurious menu. The other extreme is actually a real staple food diet, and this is a family in Africa. And what you can see here, that they are, the family in Germany was eating stuff from the food industry, and these people are eating agriculture products, so they convert the products themselves into food, so they don't need an industry to do this. This is proper food, so in the book also shows how many calories and proteins are in this, and this is really, this is proper food. So these are the extremes, the luxurious in the global north and the more staple food diets in the global south. But all these patterns are changing. This is a picture from Van Gogh, 1870. It's in the Netherlands, and it's called The Potato Eaters. It's a rather famous painting, but it shows a family in the Netherlands having their meal, and they have a only thing they were eating was potatoes. So they are really on a staple food diet. So and the Dutch also, 150 years ago, most of them were on staple food diets. Well, and the rest of the world is changing. So the McDonald's is in China, is in India, is in Africa. So all over the world, the consumption patterns are changing and to more luxurious. And it's likely that this has a huge impact. So the present system has a huge impact. And in the present system, a large share of the population is still having staple food diets, but most of the countries are actually slowly changing to something else. And then the question comes up in well, if everything is changing and if people are changing to more luxurious diets, what will be the influence on the global scale? So we did some research on this. And so this question on, okay, people are going to eat something else. What will be the overall impact? And we did a research on it, that's later, so that's 2011. And we tried to figure out if we could make a very simple model to evaluate what would happen to changing consumption patterns. And what we did was actually have a look at this consumption. And this is what we did. The upper figure here shows the meat consumption on a global scale, and the one below is the GDP per capita. And you can see that there's some relation between meat consumption and GDP. And what we did in the next step was actually making a graph for 50 years, where on the bottom line we show the GDP per capita, and here is the percentage of the calories in the menu that are from animal origin. And it's different countries. Over here it's China, here's the USA, there's France. And if you make a very simple model of this, it's a rather straight line. What we can see is that and it's more, I'm not saying that this is the truth, but it's trying to understand what will happen. So what you can see is that from $10,000 per person, the meat consumption actually remains the same, because that was our starting point. Assume, well, if we know there's a relation between meat consumption and GDP, are we going to have a full meat diet when we get richer and richer? And that was our first ideas. And then we thought on, are there people on this globe that actually have 100% meat consumption? And so what will happen if we get richer? But you can also think it the other way. Are there people on this globe that having a full 100% meat consumption? Does anybody in the audience have a no? And now Bajal has to look for. I can't see the people.
Yeah. What's your question? Would you please repeat your question so that?
Yeah. So, do you know whether there's people on this globe having 100% meat consumption?
Yeah. So, does anyone in the class knows that if any country has this 100% meat-based diet, so they eat only meat, nothing else? Any input from anyone in the class? Is there any people around the world or any community? Is that the case? Anand?
Maybe
Yeah,
in the Arctic region.
in Arctic region where things are cold. Yeah.
Yeah, that's in
And
Arctic regions. That's the areas where people have 100% meat consumption, simply because nothing grows there. It's too cold. So if you live there, the only thing you can do is eating fish and seals. So there's some area in this globe where people have 100% meat. But the interesting thing of this communities is that they are extremely poor. So in principle, they are somewhere here in the graph. So they are poor, but eating a lot of meat. And there's research done on what's happening to these people when they get richer. And as soon as they have more money to spend on food, they start to eat pasta and tomato sauce. So it's 100% meat is not something that people like. They like a more variety in their meals. So you could say that about 35% of the meat from animal origin is the kind of stable thing where we get in if we have free choice on what we can eat. But if you have a large, so what you can see here is that there's a whole series of West European countries that are on this 35% line for already 15 years. But we also see China going here. So in a time lap of 15 years, the Chinese population doubled its meat consumption. So that's extremely fast change. So changes in consumption pattern can really emerge very fast. So we use this extreme simple model to calculate the future. So this idea of the relation between GDP and meat consumption is already, so this is old material that we did ourselves, but if you go on, also from our World in Data, where you can find this, over here you have again GDP, and this is, and what you see here is that if people get richer, they also start to eat less cereals and roots. There's also graphs on meat consumption per capita. You see also this increase. So this is more or less general knowledge nowadays. And we also know that this is happening for vegetables. So this is the vegetable consumption per capita. And it also shows that the high countries of the wealthy countries are eating a lot of vegetables. So that's something else as staple food. Staple food is wheat and beans. And vegetables is more or less considered as a kind of luxurious thing. So if countries get richer, the diets change to more meat and more vegetables, but also more drinks, so more beer and wine. And they change from carbohydrates to fats. That's what we see in general when there's increase in economic development. So what we also see is that the real changes emerge between the 2000 and the 10,000 GDP dollars per person. And there's a lot of research done on this, and that's the nutrition transition. And if you're interested in this, is a nice search term if you are looking for more information on this. But okay, we know that in future, that when countries get richer, they will have a more luxurious diet, and how large is the effect? And now you can make a very simple model, because you can estimate some future GDPs in a country. So you go, the World Bank is providing estimates for this. So in principle, you can read in statistics what the GDP in 2050 is in whatever country. And if you apply this very simple model on, well, from $10,000 per person, everybody is having 30% of having a luxurious diet, you can simply calculate what will be the diet in the future. So what we did is this. So this is the number of people estimated. Yeah, it's a bit outdated, but in principle, this is number of people expected or that have been there in the last, over a century actually. And if all these people were having a very simple diet, this would be the environmental impact. So the simple diet, it's just linear. And so if people are only eating wheat and potatoes, then the environmental impact of these people is only related to the number of people that are consuming this. But people are not in staple food diets. So what we've seen is in 1960, there were 0.6 billion people having a luxurious diet. In 2010, there was already 1 billion. It's expected to be 3 billion in 2030 and up to 6 billion in 2050. So in 2050, there will be 9 billion people having on this globe, or 10 billion. But that's not the real cause for the environmental impact. The problem is that 6 billion of these 9 billion are actually having a luxurious diet with meat and other demanding products. So the environmental impact of the food system is not caused by the number of people that are around, but by the number of people that having a luxurious diet. So on a global scale, it's for future and the environment, it's not number of people, but it's what they are eating. So what we can, if we, based on this extreme simple model and the straight line, etc., we can say, well, the environmental impact of food will double just based on the fact that people are starting to eat more luxurious diets. And this is the present impact, environmental impact of food in related to a couple of environmental issues. So what you can see here is that for the global change issue of greenhouse gases, the food only contributes 25%, but in land use, agriculture is already taking 50% of the available land. Fresh water is already 70%. There's nearly 80% of the eutrophication is caused by this food consumption, and biodiversity is really affecting large. But this is the present situation, also based on this Poor and Nemecek publication I mentioned earlier. But if this is the situation presently, and you know that the environmental impact will double, then it's quite obvious it's not going to fit. Right? Because presently already 70% of the fresh water is in some way used in agriculture. By no way we can double. So this is where we are and the problems that will emerge. So we should think on this diet things. So what is in a diet with a low environmental impact? Yeah, less meat. There's not really a need for being really vegetarian, but also no nuts. So a lot of the vegetarian alternatives are based on nuts, but the nuts turn out to have a very large environmental impact. You can see it in the graphs I showed earlier. But also no exotic vegetables. So no, you should eat the local ones and not ones that are grown in heated glass houses or ones that are flown in from faraway areas. But that means that the choice of what we can eat, and this is a slide I use in the Netherlands, and it might not meet the choices that you have to choose, but you should also restrict your coffee and your tea and consumption, and be using oil as a way to cook is also, because oil is also having a high demand, you should also reduce that one. So this is what we know. We should go for diets with lower environmental impacts. And in the Netherlands, there's a lot of attention to this. So there's all kinds of programs on vegetarian alternatives in our meals and what you should eat to reduce the environment. So there's a lot of awareness there. And then we get, so a lot of people are wanting to change or are interested in it. And then we come to a very strange situation that if all the Dutch change to vegetarian meals, it won't improve our environment. And this is the case, and it has to do that we are one of the biggest exporters of meat and dairy products in the world. So 70% of the dairy and the meat we are exporting is not for, of 70% that we produce is not for our own consumption. So in the Netherlands, we have a very strange situation. There's a very small country. We have large amounts of cows in it, but the country is that small that we can't produce the livestock for all these cows. So what we do, and we export all the milk we produce, and that's going in general to Germany, but you can also find our milk in China. But by no way we can feed this livestock by our own production. So it's soybeans that's actually coming from Brazil. So this is the food situation in the Netherlands. We produce an awful lot and we have huge environmental problems, but it's not our own food that we are producing. And this system has also a rather nasty result, is namely soybean is coming in, milk is going out, and the manure remains. And that's one of the biggest problems in the Netherlands. You have now awful lot of manure, and it's causing huge environmental problems. And just to give you some idea, well, this is our cow. 70% of the dairy is exported. And that means that for each kilogram of exported cheese, there's 30 kilograms of manure remaining in this country. And by no way we can get rid of this, and it's really damaging our environment because there's so much nitrogen and phosphates running into rivers and in nature. So there's a share of the population being very proud on being the largest meat exporter in the world. But I think it's not that wise that we choose for this way of keeping our country running. And it's not only the milk, because also we export 70% of our pork production, also fed with soybeans from Brazil. All our vegetables are also 70%, and they are grown in heated glass houses, are exported. Also to a larger share to Germany. For Germany, for instance, is not growing any tomatoes itself. It's only getting them from the Netherlands or from Spain. So, and it's a clever decision from Germany because all the pollution is in other countries and they have the consumption. But it's also the flowers. I'm famous for our flower bulbs, but it's growing flowers is using so large amounts of pesticides that it's really affecting health in most of the villages that are in those flower bulb areas. So we have a rather silly environmental or economic system that we produce an awful lot of food and vegetables, we earn money on it, but we are having the problems with the environmental impact of this this way of running an economy. So this is my concluding slide. So that present system has already a huge impact. What we know is that the population is going to increase, but the increase in welfare will lead to more luxurious diets, and actually this will have a far larger impact than the extra number of people coming in. So what we need to develop in the coming decades and yeah, you're a new population of students, so you have to do it, because I'm going to retire, so it's up to you to solve this. But we need very clever people that can develop food systems that include both a production system that produces the proper stuff, but it should also produce the healthy food. So it's not making large areas of soybean, but we should first decide on what's a healthy food, and then we should figure out what's the best way to produce this for on a global scale. So it needs a different way of developing the whole system.